This is practice A for section 5.1. This is the back of the worksheet. We're going to find coordinates of the endpoints of each mid-segment of triangle PQR. So here's triangle PQR. It kind of looks like points S, T, and U are midpoints, but you don't really know. How would you figure out if point S is a midpoint of segment PQ? Well, you're going to take your x's, 0 and 6, you're going to add them and divide by 2. Take your y's, 2 and 4, add them and divide by 2. The midpoint of segment PQ is the ordered pair 3, 3. And if you look at that, 1, 2, 3, 1, 2, 3, that is where S lives. S is the midpoint of that segment. Now, I have the work shown here. T is the midpoint of this segment. U is the midpoint of this segment. So find the coordinates of the endpoints of each midsegment. They're actually already there. You just have to count them. That's where S, T, and U live. Number 12, use slope and distance formula to verify that the mid-segment theorem is true for segment ST. Dang it, and I wrote it out for the other one. Okay, well this will work. I'll show you how to do it for a different mid-segment. You can do it for segment ST. So don't copy this down like this is the answer. You need to do it for segment ST. I'm doing it for segment UT, I think. Right? So the mid-segment theorem says two things. It says that this is parallel to this. So how do you check if segments are parallel? Count the slope. What's the slope of segment UT? Well, we're going over 1, 2, 3, and up 1. So rise 1, run 3. Do the same thing for this segment. What would the slope of this segment be? Well, from this point to this point, I'm counting over 1, 2, 3, and up 1. The slope is 1/3. Okay, this guarantees equal slopes. That guarantees that the segments PQ and UT are parallel. Now, the second thing the mid-segment theorem tells you is that this is half the length of that. So we need to use distance formula to calculate that. So how far is it from U to T? Well, here's U, here's T. Let's use the distance formula. Let's do 5 minus 2. And let's do 1 minus 0. I know 5 minus 2 is 3. 3 squared is 9. 1 minus 0 is 1. 1 squared is 1. So this is just the square root of 10. I didn't even use my calculator. P to Q, how long is this segment? Well, P lives at 0, 2. Q lives at 6, 4. So let's do 6 minus 0. And let's do 4 minus 2. And again, I'm going to attempt to do this without a calculator. 6 minus 0 is 6. 4 minus 2 is 2. 6 squared is 36. 2 squared is 4. This is the square root of 40. Now, you may ask yourself, how do I know this is twice as big as that? If you look at it, does this look twice as big as that? It really doesn't. But here's what you know about perfect squares. The square root of 40 is really the square root of 4 times the square root of 10. Because 4 times 10 is 40. The square root of 4 is just 2. So notice, that's your midsegment. That's the other side. See how it's 2 times the square root of 10? It is exactly twice as long. I know it doesn't look like it to you, but this is twice as long as that. And that's your proof. Okay, now for this one, you are not doing this midsegment, or this midsegment, you're doing this one. Okay, so I showed you how to do segment UT, you need to do segment ST.